Okay, today we are going to discuss the applications of trigonometry. It's a very important chapter. That is, you can find the height of a tree, suppose. If you know the angle which your eyes make with the top of the tree and also this horizontal line. If one of the sides is given, you can find the other by making use of the trigonometric ratio. This is the beauty of this trigonometry actually. For this, there is this right angle triangle, because trigonometry is based on this right angle triangle. This is very, very important. If there is no right angle or right triangle, then the concept of trigonometry is not there. Suppose ABC is a right angle triangle, right angle at B, and this is the angle theta, and if you are the observer and you are viewing an object which is, this is called, the AC is called the line of sight, and this is the horizontal line. And suppose you are seeing an object which is above this horizontal line. Your eyes will make an angle. This angle is called angle of elevation. Angle of elevation. Let me repeat this. If you are an observer and suppose a bird is sitting on the top of a tree and you are viewing that bird, your eyes will make an angle, and that angle is called angle of elevation. Obviously, this angle of elevation, when your eyes make an angle to a point which is above the horizontal line, this angle is called angle of elevation. Second angle is angle of depression. Angle of depression means when you are viewing an object, if this is the horizontal line and here it is an object and you are viewing this object, this angle is here, this is called angle of depression. So when the object is below the horizontal line and you are going to view this angle, this is called angle of depression. Very important, these 2 points. Angle of elevation, when the object you are viewing is above the horizontal line, that angle is called angle of elevation. And when the object which you are viewing is below the horizontal line, that angle is called angle of depression. Now the beauty of this trigonometry is that you can find the height of a tree or height of a tower without actual measurement. If you know the angle and at the horizontal line or any 3 sides of this right angle triangle, either AB, BC or AC, if you know one of the sides of the triangle, you can find other 2 sides by making the use of this trigonometry, T ratios. And let us recall, we know that sine of an angle theta is perpendicular divided by hypotenuse, and obviously cosec is the reciprocal of this, that is hypotenuse divided by perpendicular, and this cos theta, this is base by hypotenuse, and sec theta is obviously the reciprocal of this cos theta, that is h by b, hypotenuse divided by base. Similarly, tan theta, we know it is perpendicular divided by base, and cot theta is base by perpendicular. So this we already know, these angles, but we have to remember them because we frequently use them, these angles. And now here, suppose this angle here, suppose BC is a tree. Let the height of the tree be h. And AB, your eyes make an angle here at point A, suppose this is 30 degree. This baseline or horizontal line from the foot of the tree to the point of the observation, suppose this is 20 meters. Now you have to find the height of the tree. Now see how much easy is this. By making the use of trigonometric ratios, you can easily find the height of the tree. Now in right angular triangle ABC, this BC divided by AB, this is perpendicular divided by base, this is tan of an angle. One thing I must make it clear here, that one side is always given and one is to be determined. The side which is to be determined should be taken as the numerator. Remember this? This is a trick. How to find the height of a tree? Suppose you are sometimes asked to find this hypotenuse AC. Then what shall you do is, you will take AC as numerator. So whichever is the side you are going to find, you will take that side as numerator. Here we take BC, this is numerator, and AB is the denominator. So we take the ratio BC divided by AC. This is equal to perpendicular divided by base, that is tan theta. And what is this BC? This is the height of the tree. H divided by AB is 20, is equal to tan 30. Tan 30 is 1 by under root 3. And by cross, H is equal to 21 are 20 divided by under root 3. Now rationalize that denominator, this is under root 3 divided by under root 3. You can write this 20 under root 3 divided by 3 meters. This is the height of the tree. So this is very simple. First of all, you should remember this, that you will involve those two sides of a triangle in which one is given and one is to be determined. One which is to be determined should be taken as a numerator. So this is the trick I must say. So this is very simple trigonometry, and you must remember this, that you will involve those two sides of the right angle triangle in which one is given and one which is to be determined. One which is to be determined should be taken as a numerator. But that is it. Once you remember this thing, and this is the very easy, then questions will be easy for you. So question number 1 of your mathematics exercise number 9.1. A circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of the vertical pole to the ground. Now again, suppose this BC is the vertical pole and this is the line or rope which is tied to the ground from top of this pole to the ground. A circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of the pole to the ground. This is given there. This is 20 meter. This is 20 meter. And find the height of the pole if the angle made by the rope with the ground level is 30 degree. Again, this angle is 30 degree. Now this is very simple. You have to find the height of this pole. Again, let BC is equal to H meters is the height of the pole, and AB, you know, this is the horizontal line, and AC is equal to 20 meters is the length of the rope, Now what you are going to find, that is the height of this pole BC. Now we know that we have to involve these two sides this time, perpendicular and hypotenuse. Since perpendicular is to be determined and hypotenuse is given, therefore we will involve these two sides. So in right angular triangle ABC, this BC, this is to be determined. We know that we should take this as numerator. BC divided by AC is equivalent to perpendicular divided by hypotenuse. This is sine theta. So what is theta here? It is 30 degree. So angle is here 30 degree. BC is H, AC is 20, is equal to sine 30 degree is, sine 30 is 1 by 2. This is 1 by 2. Sine 30 degree is 1 by 2, yes. So this is 2h by cross is equivalent to 20. What is h? It is 20 divided by 2, 2 tens are. So h, the height of the pole is 10 meters. This is your answer. So the height of the pole is 10 meters. Question number 2 is, a tree breaks due to the storm and the broken part bends and touches to the ground, makes an angle of 30 degree with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Now again, question number 2. So this is the beauty of this trigonometry, that you can find the height of the tree without actual calculation, without actual measurement. Now here, suppose this is the tree, AB is the tree, and this tree is broken due to wind, and broken part touches the ground. Say this is C, this is D. Touch the ground which is 8 meters away from the foot of the tree. Now here base is given, this is 8. What is the height of the tree? Actually this is AD plus DB, or you can say AB is the height of the tree. But this broken part is touches the ground and B reaches here. Sorry, this is B here. The tree breaks from here. Now, what is the height of the tree? Height of the tree is let AD plus BD. This is actually tree. This plus this. This side plus this side is the tree. This is the broken part. BD is the broken part and AD is what is left over. So AD plus BD is the height of the tree. Is the height of the tree. Now this AB is given. AB is equal to 8 meters away from the foot of the tree. And the angle with the broken part touches the ground makes is 30 degree again. Now we know that we shall involve those two sides of the triangle in which one is given and one is to be determined. We need this AD perpendicular and base is given. Base is 8. Now in right angular triangle, ABD, this AD divided by 8, perpendicular divided by base, or we can write here AD divided by AB is equal to tan of angle, tan 30 degree. So AD divided by 8 is equal to tan 30 is 1 by under root 3. Yes, it is 1 by under root 3. Or you can write here AD is equivalent 8 by under root 3. This is your AD. Name this first. Second, we need this BD. BD is the hypotenuse here. Now, in the same triangle, in right angular triangle, ABD, this BD divided by AB, this hypotenuse by base. Base by hypotenuse is base, hypotenuse divided by base. Base by hypotenuse. Base by hypotenuse is cos theta. What is hypotenuse divided by base? It is sec theta. So this is sec 30. So BD is BD, this we require. AB is 8 is equivalent. Sec 30 is, what is sec 2 by under root 3? This 2 by under root 3. Or you can write this BD is equivalent. A2s are 16 by under root 3. This your BD. Now height of the tree is AD plus BD. Height of the tree. This is AD plus BD. BD is the broken part. So AD is, that is AD plus BD. What is our AD? AD is 8 divided by under root 3 plus BD. BD is 16 divided by under root 3. Now denominators are same. 8 plus 16, that's 24 by under root 3. Now rationalizing the denominator, under root 3 by under root 3. So this is 24 under root 3 divided by, under root 3 into under root 3 is 3. 3 ones are 3 8s are. So 8 under root 3 meters. This is the height of the tree. This is the height of the tree. So this is very simple, but very important question is. Inshallah, tomorrow we shall discuss question number 3 onwards. There are so many questions. Actually, this exercise has got 16 questions. 16 questions. Now, tomorrow we shall discuss question number 3, question number 4, 5, and so on. Till then, Khuda Hafiz.